Hi. So we're going through a PAT paper in 2016 looking at question 21. So in question 21 we're told that we have a sphere of the same refractive index as air, which is 1. And we have a laser beam is shone through some fluid of refractive index n on the outside. We're asked, if a beam of light follows the arrow and strikes at A, what must the refractive index of the fluid be, n, such that the beam is refracted to travel at 45 degrees to the line AC? Okay, so let's draw on what we've been told. So we want it to travel at 45 degrees to the line AC. So where is the line AC? Well, it's here. Now, this can be quite a confusing looking question because it involves a sphere, and we're very familiar with objects striking planes. But here we have a sphere and it's a curved surface, and that might be confusing. The way to think about it is to imagine that you're striking at the tangent to the sphere. So instantaneously there is a tangent that comes from here, touches the sphere and passes. It's essentially a plane that is tangent to the sphere. So we're going to imagine that it's actually striking this surface as opposed to striking a curved one. Okay, so we know it's going to be refracted into the sphere. We've been told that you want it to travel at 45 degrees relative to AC, and it's going to strike with some angle theta. So we know from Snell's law that n1 sine theta 1 equal to n2 sine theta 2, where m1 and n2 are the refractive indexes of the material 1 and material 2, and theta 1 is the angle of incidence and theta 2 is the angle of refraction. So in this case we know that n2 is 1. We've been told the sphere has refractive index 1. And we know sine theta 2, well, we know theta 2 is 45 degrees. So sine theta 2 is root 2 over 2. So this tells us that n1 sine theta 1 is equal to root 2 over 2. And therefore the n, the refractive index of our fluid, is equal to 1 over sine theta 1 times root 2 over 2. So we simply need to find our angle of incidence, and therefore we can find the sine of theta 1 and find our refractive index. Okay, so what do you know about this angle? Well, we know that angle was also the same angle as down here, because we have that this line is parallel to this line. Okay, well, what happens if we extend down this line here? We see we get a right angle, a triangle. And we know that the radius of this triangle is 2 meters. So this tells us that the length of this line here, the diagonal, is 2 meters. And we know it strikes at a height of 1 meter. So we see that this side is of length 1 meter. Well, that's very useful. So we can use that to say, in fact, that sine of theta is equal to opposite over hypotenuse, or 1 over 2. And therefore, 1 over sine of theta is equal to 2, which implies that n is equal to 2 times root 2 over 2, or simply our refractive index is root 2. Okay, the next part of the question says another beam strike at A. At what angle to AC must it strike such that it's totally reflected? So what does it mean to be totally reflected? Well, that means that none of the ray is going to be refracted into the sphere. So that means the ray is going to strike the surface and be reflected off. So what's the minimum angle, the minimum angle such that it strikes and this happens? Well, imagine the limiting case. That'll be when it strikes the surface and just passes along the surface. It passes exactly along the tangent. If it goes any more, it's inside, any less, it's not the limiting case. So the limiting case, it strikes and goes directly along the tangent. So what does that mean? Well, that means that in fact the second angle, theta 2, the angle relative to AC on the inside, is 90 degrees. So the rays are going to come along here and then be refracted like this. So theta 2 is 90 degrees. So let's write that down. So in this case, theta 2 is equal to 90 degrees. And we know that n2 is equal to 1. And therefore we require n1 sine theta 1. Well, n1 is root 2. So we require root 2 sine of theta 1 to be equal to 1. Well, therefore, theta 1 is equal to pi by 4. So you're required to strike an angle of pi by 4. And in fact, what we notice is that this will also work for theta 1 strictly greater than pi by 4. Because you see, if we increase the angle here that it strikes at, so if it strikes, say, like this, it's still going to be completely reflected. It will come off like that. So this is just the absolute minimum angle it must strike at, such that it's totally reflected. So our answer is theta is greater than pi by 4.